Thanks everyone for joining our session tonight. And tonight I am your guest speaker, Saim Safdar, community manager at Cloud Native Islamabad, and we presenting stuff from all around the cloud native ecosystem, from container technologies to orchestration technologies to cloud native monitoring tooling to container runtimes to the storage and networking interfaces, all kind of the cloud native ecosystem evolving every day. So we keep track of these things and find cloud native experts all over the world doing webinar to help you get up to speed on cloud native technologies. I'm really happy uh, tonight's session, and we are all talking about the most powerful Kubernetes IDE, the Lens from Mirantis. And I have a speaker that speak about what Lens is, what is therefore, how it's originated, what Mirantis is doing for doing this project, and what's coming up in the 2021 in the Lens ecosystem. So our guest is tonight is Lauri Nevala. He's a core member of Kubernetes Lens team from Mirantis. He is a staff engineer at Mirantis, and I'm really appreciated he take his time and share his knowledge with our community. Over to you, Lauri Nevala, and really appreciated your efforts for being connected with us.
All right, thank you very much. Nice to be here to talk to you about Lens Kubernetes IDE. Something about me. I'm Lauri Nevala, and I'm staff engineer at Mirantis, and I'm one of the core developers of Lens team at Mirantis. And you can find me from Twitter and GitHub with these handles. And my history with Docker and containers started back in 2015 when we went to production with Docker version 0.6. So Docker was very new thing back then, and we were brave enough to try it out in production. Maybe we shouldn't have done that, but we did. And we saw that Docker and containers will be the future, and we started the startup, and we built our own Docker or container orchestrator, because back then there wasn't any other options. Docker Swarm wasn't there. Kubernetes was, but it was only in Google internal project. So we created our own orchestrator. But Kubernetes evolved and gained more and more people to use it. So we switched also to Kubernetes. But it was so damn hard to get started with Kubernetes. So we first built our own distribution that made very easy to set up Kubernetes cluster. But after having many clusters, so it was very, very hard to see what is actually happening inside that cluster. So we came up with the idea of Lens that will handle multiple Kubernetes clusters, and user is able to see what is actually happening there. And now I'm at Mirantis, and we are continuing the development of Lens project. And today here to speak to you about Lens. So, how did we get here? If you are doing any server-side or web application development, you are forced to get in touch with Kubernetes at some level. So you need to know something about Kubernetes. But it's still difficult and complex. Not necessarily, but if you are using primitive tools for the job. So, for example, kubectl is a great tool if you have only one cluster to manage. But the problems start when you are having many clusters, you have to switch between contexts and always be sure that you have access to right cluster to execute those commands and whatnot. And in the Kubernetes ecosystem, there are great tools, but those tools are a bit separated. There are great tools for ops and IT admins to manage Kubernetes clusters. And there are great tools for developers to deploy and manage those workloads on top of Kubernetes. And we are trying to aim with Lens that we will combine these two worlds. So we provide a tool that is very, very useful for both ops team and developers. So that's our target. And how we are going to achieve this is with Lens, the Kubernetes IDE. And people might wonder what the IDE means in this Kubernetes context. So it means that all essential Kubernetes technologies and tools are integrated seamlessly together. So it's the purpose of streamlining Kubernetes dev activities like deploying, running, and debugging, and deliver that as a single unified environment with a great user experience. So it doesn't mean that we are replacing, for example, VS Code. No, we are just providing tools to Kubernetes developers that are facing Kubernetes on a daily basis. So the Lens is all you need to take control of Kubernetes. So it's a standalone desktop app, so you don't need to install anything inside the cluster. And the connection from Lens app is made via Kubernetes APIs directly. It provides complete situational awareness for all clusters and workloads, no matter are those running on premises or on any public clouds. And it's designed for devs and ops who are working on Kubernetes on daily basis. So we are trying to lower the barrier to get started with Kubernetes. And of course, improve productivity and quality of life of those users who are using Kubernetes. And Lens, it's working with any certified Kubernetes distributions. And it's fully open source and free of charge. Some statistics. It's number one of Kubernetes IDE. We have over 12,000 GitHub stargazers and over 120,000 users with 2.2 million downloads, and these numbers are increasing every day. Here are some features. So first, Lens is a multi-cluster manager. So it works with any number of Kubernetes clusters and provides quick and easy way to work on workloads across different clusters. And a user can simply add clusters by importing associated kubeconfig file and select the correct context from that file. And once added clusters, it's very easy to switch between those clusters and see what is going on up there. And like I said, it works with any certified Kubernetes cluster. It can be K0s or Amazon EKS or AKS from Azure or anything. And it's single unified IDE for all clusters. No need to install anything inside the cluster. And when Lens is connecting to Kubernetes cluster, it will rely on a kubeconfig file that is provided to Lens. And it will use the kubeconfig file authentication mechanism to request the correct token and use that token to request Kubernetes API. And it's respecting Kubernetes RBAC rules, so user will see only those resources that they are allowed to access. And it doesn't need admin level privilege. So you can work with Lens with your kubeconfig file that you are using with kubectl. So no need to generate anything else. With Lens, you can manage all Kubernetes resources, and that includes also custom resources. So all are there, and Lens is providing a real-time view to those resources. So if there are something happening inside the cluster, some pods are removed or deleted or created new deployments, you will see those in real time on the dashboard. And there's built-in resource editor, so you can update and edit those Kubernetes resources from the dashboard. And Lens will also hint if there are any issues with those resources. For example, if for some reason image cannot be pulled, or some readiness or liveness check is failing, you will see that on the dashboard. And Lens will also provide access to pod shell and also to node shells. So you can jump into node shell directly from the dashboard. You don't need to have any SSH keys or anything, just works. And you can also open port forward to pods and services from the dashboard and request those services from the local host. One very cool feature of Lens is the smart terminal with kubectl. And what is the smart part here is that Lens will automatically switch the version of kubectl to match the currently selected Kubernetes cluster API version. So you can have Kubernetes clusters that are running different versions of Kubernetes, but with Lens you will always have the right version of kubectl. And also Lens will switch the context automatically. So every cluster will have the right version of kubectl and right context in place when you are running that terminal. And there's also Helm binary bundled, so you will have you can interact with Helm too from the terminal. Lens has also built-in integration with Prometheus to visualize resource usage. So the basic resource usage metrics include GPU, memory, and disk with total capacity and actual usage, and also request and limits. There's also ingress metrics, and you can see that how many bytes are sent or how many success or failure requests is existing, and also request duration and response durations. So you can see how your ingress controller is acting. And you can also see persistent volume claims metrics. So you can see how many bytes are stored in persistent volumes and what is the capacity there. And also those visualizations are automatically generated for each supported resource type. So on a deployment level, you can see the overall resource consumption. It's calculated from all the pods that are belonging to deployment. And Lens version 4.0 introduced extensions API, and that opened very interesting options to community to extend the Lens experience. So the extensions API may be used by the community and vendors to develop Lens extensions. So organization may leverage the extensions API to develop some new features to enrich the Lens UI. And of course, if they have some internal use cases, they can create extensions for those specific use cases. So if the use case is so narrow that it's not suitable to all Lens users, they can still create an extension and use that for their own Lens installations. Also, Lens is supporting Helm charts and releases. So there's a built-in integration with Helm to manage Helm charts and releases. And users may add Helm repositories from cluster settings, and then they will see all those Helm charts that are coming from those repositories on the dashboard. There's a Bitnami repository added by default by Linux, so there's something ready in that section for all users. But those repositories are totally customizable, so you can choose what to display there. And the new Helm charts installations are very easy. You can just select the Helm chart that you want to install, give it some name, and provide values that you want to use with that release, and hit the install button, and Lens will create that Helm release for you. And once the release is there, you can upgrade and do rollbacks too. So it's providing full lifecycle management for Helm charts. So, what's coming next? Lens 4.1 is coming very soon in this month. I think we will publish the first beta release today. And there's a quite cool feature coming with that release called Command Palette. If you are familiar with VS Code and there's similar kind of command palette that you can easily and fast execute some commands from the IDE. So something similar that is coming to Lens. So you can hit some shortcut key and execute command like switch cluster or display port locks, open terminal, and so it's decreasing the actions that you need to do with mouse. So it's providing easy access to resources with executing commands. And there's also some optimizations made for non-admin users. So if user is not cluster admin, but still having access to multiple namespaces, we have streamlined the user experience for those kind of users. And of course, there's some improvements to extensions API. So people are developing extensions and notice that some things are not yet supported, something that they want to use in their extension. So we are constantly adding new features to extensions API too. And in a bigger picture, we are bringing to Lens features for enhancing Kubernetes developer workflows, both on locally and remote, and some features for enabling teamwork, some collaboration stuff, and of course constant updates to improve UX, fixing bugs reported by our users. And there are also lots of other very cool features. So please see our GitHub repository for more details. It's lensapp/lens on GitHub. We are putting all our issues there. So you will see those in there. It's very transparent process that we are doing. All right, sounds very cool, isn't it? So how to get started? To get started and download Lens IDE, go to k8slens.del, and there you will see the download button. And by clicking that, you can download the Lens application. What do you need? You need some supported operating system. And currently we are supporting Windows, macOS, and Linux. For macOS, we have a DMG package, and Homebrew is supported too. For Linux, there's ready-made snap and app image packages, and Lens 4.1 will bring also Debian and RPM packages. What else do you need? You need to have a valid kubeconfig file. So if you have already access to some Kubernetes cluster with kubectl, I think you are good to go. The Kubernetes server URL defined in kubeconfig, it must be reachable either directly or by defining HTTP proxy in cluster settings. So you must be able to connect the Kubernetes cluster from your local machine. And of course, those credentials that are in kubeconfig file, those must be valid. So if there are any expired tokens or anything, then Lens cannot connect to Kubernetes cluster, which is quite natural. And one gotcha for users that have Kubernetes cluster that is relying on exec command in kubeconfig file. That exec path must be either absolute path or available in global path. Otherwise, Lens cannot execute that binary. So it must be available for Lens application to execute that. The issue is that some shell's initial scripts might add that binary into path, but when opening Lens, those initial scripts are not executed. So you need to explicitly put it in path or use the absolute path. Couple of words about Starboard. So Lens doesn't care if the user cluster admin or user with limited access. It will work. But user must have access at least to one namespace in the cluster. Of course, if the user doesn't have access, there's nothing to show on Lens, but Lens is relying on that at least one namespace is accessible. And Lens will resolve those namespaces. It first checks that is user allowed to list namespaces. And if yes, it will use those namespaces that are returned from Kubernetes API. But if not, user can configure those namespaces that he or she has access in cluster settings. And Lens will find those namespaces from there. And if nothing else is matched, then Lens will check from kubeconfig file if there are namespace configured in there. By that way, only one namespace is then allowed in Lens, because you can only configure one namespace in kubeconfig file. All right, and if all these requirements are met, you are ready to start with Lens application. All right. When you start Lens first time, the initial screen looks like this. So it's empty, and you need to add clusters. Adding clusters it's very easy. You just hit the plus icon, and Lens is automatically providing Kubernetes context from default kubeconfig file, but you can select another kubeconfig file from a file system, or you can, if you have some text file or kubeconfig content somewhere, you can copy that to clipboard and paste as text in Lens. And then you just select the correct kubeconfig, context from kubeconfig file and click Add Cluster button, and Lens will open the dashboard. If having multiple clusters, I mean so many that the space here is crowded, you can easily group those clusters into workspaces. So workspaces are something that will group clusters. You can have, for example, clusters for each customer, or you can have different environments, production and staging, and separate those clusters by that. And you can then switch between workspaces and see those clusters that you want to see. All right. And after you have added the cluster, you can edit those settings. You can see some connection status and detected distribution from preferences. You can give or override the name. By default, Lens will use the context name of kubeconfig file, or in kubeconfig file as a default name, but you can override because sometimes those context names can be very cryptic. So just give some meaningful name here. You can move the cluster to another workspace, and you can also download, upload new icon for that cluster that is visible on the cluster menu to help to recognize what is the cluster and separate that from other clusters. And you can also set the terminal working directory here. So if you are developing some application on specific cluster, you can give path to that application on here, and when you open the terminal, you can execute commands from that directory. And here you can override or keep the namespaces that user access. And here are also some features, cluster features that you can install or uninstall. Those can come from Lens application itself or from extensions. All right. And like you see Lens is providing access to Kubernetes resources. This cluster overview is view for cluster admins. So you will see the overall status of cluster, and if there are any issues inside the cluster, those will be raised here. And on node section, all the nodes are listed. I'm currently using Minikube cluster, so it will display only one cluster, node. And by clicking the row, I will see the node details. And I can see here all the details of nodes, what pods are running into Node, and I can coordinate the node and train the node. I can jump into node shell, so it will now establish connection to node and give me a bash session in that node. So if you need to jump into node and debug something or inspect something in details, you can do it from Lens dashboard. All right, then we have other resources. We have workloads. We can see all the pods that are running. We can filter those by namespaces. We can see also the pod details, see the metrics, and we can see also logs. And we have some search functionality here. If the logs are if you are having a lot of logs, you can just search the term that you want to see on the logs. And Lens will highlight those items. And if the pod is having multiple containers, those containers are listed here that you can switch. And you can see the details from all these resources. And for example, if you have a deployment, you can scale that deployment from Lens app. And you can see in real time how Kubernetes is orchestrating those pods inside the cluster. And basically, you can see all resources here. There's a config maps and secrets. There's a network layer. You can see services, ingresses, and network policies. And in storage section, you can see persistent volume claims. And what is very cool here, if the persistent volume claim is not bound to any pod, you can easily spot those volume claims that and delete those if those are redundant. And same goes to persistent volumes and namespaces. And you can see all the events from the cluster. And then we have this app section. This is containing the Helm integration. So by default, there's a Bitnami repository installed. We can search Helm charts. You can see, for example, this WordPress. And by clicking install, of course, it will display the details of chart. You can see the README from that and figure out what it's actually doing. And you can install it. So when installing Helm chart, Lens will display by default all those values. So you don't need to jump to README file or GitHub or any documentation to see what are allowed values here. So we can give some name and override these values, default values. For example, let's say that we don't want to use load balancer type. We want to use cluster IP for the service that is created. And then we just hit install button, and Lens will install the Helm chart. We can view the release, and we can see that release in workload section that Lens or Kubernetes is deploying that. And from port list we can see, okay, now the persistent volume claim is not there yet, so the MariaDB is pending still. And if we wait a bit, yeah, now it's already there. And now WordPress is not ready yet. Most likely it's trying to verify the database connection, and now it's also ready. And if we look the service, we are able to see this WordPress service using cluster IP type as we defined. And by clicking this port, we can open this service on a local web browser. It's using this localhost address, and Lens will, or kubectl will forward that port to Kubernetes cluster. So it's very handy to debug or test those Kubernetes remote services from local machine. And like I mentioned about terminal, so it's like this. It's visible on the bottom of the Lens application screen, and we can open that by clicking. And it looks like very normal cell. So we can verify that it's using the bundled kubectl, and it's using 1.20 version of kubectl, because our Kubernetes cluster is 1.20 version. And the Helm binary is also there. We can see the same information from terminal. And we can also execute commands. Let's say deployment my-nginx. Let's see, we have now, let's go back to 2 replicas. And once executing these commands, we can see the current status on dashboard. And how users or developers can extend the Lens application? We have a extensions API, and for examples, Aqua Security has made extension that will display the security scanning reports on resource details. So for example, here if there are any vulnerabilities detected, the Starboard extension will display those here. All right, I don't show that at this time, but yeah. Okay, it's there, but for some reason it cannot be matched. So there's one vulnerability report scanned based on image Nginx Alpine, but no issues found on that image. So this is one use case of extension. One use case is having some chaos engineering. So there's a Space Invaders game that might be familiar to someone. And this is ported to Kubernetes so that actually all the enemies here are actually Kubernetes pods. So with this game, you can actually test how your Kubernetes cluster will survive if you shoot down some pods. So we can test, for example, kill some pods here. Okay, I missed that. Let's. Okay, now we shoot something. And we should see here how Kubernetes is actually restarting those containers. Maybe at this time I didn't hit any crucial component. I have this. Yeah, I can see that kube proxy was recreated 20 seconds ago. So this is one use case. Someone says that you should do this on your production clusters too. So the cluster should survive despite you shoot any ports from the cluster. But because this minikube is a single node cluster, it won't survive if you shoot down some crucial ports, and it requires that you restart the minikube. And one example of extension is this kind of resource map that visualizes those Kubernetes resources and their relations. And if you have a pile of Kubernetes manifests, it's super hard to spot if there are any issues or misconfigurations. But with these extension, you are able to see how those resources are connected together. For example, if I open this default namespace, I can see here my Nginx deployment, and here's an Nginx service, but these don't have a link between those resources. So we can see that my deployment is using run equals my Nginx as selector, and this selector, okay, I can spot here some typo on the selector. So let's fix this. Let's fix the selector to use my Nginx, and we can save this, and we can see now, okay, now those resources are linked perfectly. And this view is also real-time, so if we scale the deployment, we can see in real time how pods are popping up and starting. All right, and some demo effect. Yeah. All right, these are some nice use cases to tell you how extensions can extend the Lens IDE, and there are multiple options to do that. So I'm sure the community will make the Lens IDE super powerful tool for both ops and dev teams. So all right, that's everything I want to cover today. To find more information, go to k8slens.dev, and our documentation site can be found on docs k8slens.dev. There's lots of information and information that I didn't mention today. To read more about Lens, go there. Thank you. And if you have any questions, I'm happy to answer those.
Thanks, Lauri. It's a very good deeper dive into the Lens, and I would see the Kubernetes as also ever evolving. There is so much going on every now and then in the Kubernetes landscape. There is so many replicas, deployments, ingresses, so many of the stuff. But it's a really very well deep dive session into the Kubernetes Lens. But one of the questions that we've gotten in an email that in 1.21 Kubernetes is obsoleting the pod security policies from 1.21, and there we see other third-party integration tools like Open Policy Agent and Kyverno, and these are default doing the open pod security policies, enforcing and validating these pod security policies. So my containers are not going to be leaking some information that didn't expect to be leaking. So these kind of information, I think so in a Kubernetes Lens, so Kubernetes Lens have that extension API, so they can support Kyverno and us an open policy agent for that.
Yes, that is a perfect match to extensions API. So open policy agent is very cool technology, and we definitely want to have that on Lens too. But since that is not the native Kubernetes resource, it's a bit out of scope of Lens IDE itself. But with extensions, that's a perfect match. Someone just develops the extensions that will display open policy agent resources in Lens IDE, and voila, it's there. It's super easy to do when we have this extensions API. We have a ready-made components to list those custom resources in a web in a list, and it should be very easy, and I'm sure it's very happy to do that also.
Yeah, and adding up to this question, some of the custom resource definition we have, they might doing injecting runtime during they have created a pod already there, and then they inject something by using the validation webhook or authentication webhooks. So do Kubernetes Lens have this kind of a dashboard or some information that when prod is created, so during 30 second or 1 minute or other period, when these injection happening and validation hooks are applied with these kind of a things. So if the user thinks that the validation hook or authentication hook are not validated or configured correctly, they might give us some pointers that I have missed something out.
Yeah, basically everything that can be found in Kubernetes resources, in metadata or status fields, Lens should be able to display those. So if that validation hook is adding something into Kubernetes resources, Lens is able to display those. And of course, if that is something that is really related to validation hook itself, so that might require to additional tweaking to Lens app itself, or it can be done via extensions. So
okay, and next question: we have different Kubernetes distribution out there. We have a K3s, K0s, Micro K8s, Mini K. So any distribution, any Kubernetes distribution, whether they are on the cloud or whether they are created just new comes out, they are by default configurable in Kubernetes Lens, and Lens have support for that.
Yes, basically Lens is expecting that the Kubernetes cluster is some level certified Kubernetes. So the API is following the standard Kubernetes API. And if you have a kubeconfig file and that points to that Kubernetes cluster, Lens doesn't care what kind of cluster it is. So just go ahead and add those clusters into Lens. It will work.
Okay. And other question that we see that people are transitioning to the service mesh technologies like have Istio or Linkerd or some kind of stuff. So whenever so currently do have some kind of a pod that have a sidecar in it that doing some kind of a service mesh stuff. Currently, do we have in Kubernetes Lens, or because we already have some projects like Yahyy or other kind of project, so they might leverage extension API. So whether user going to the Yahyy dashboard again from switching back and forth, might be they have a way to see that kind of details in a Kubernetes Lens in a precise way.
Yeah, I can see two options. With Lens extensions, you can maybe it's not point to override or rewrite those dashboards into Lens, but what Lens can do is display the limited subset of those resources on Lens IDE and provide link to actual dashboard for more details. So the Lens IDE is the entry point for those dashboards to get more. But for quick access, you can see on Lens what is happening there, and if there are any issues, you will recognize that and jump into dashboard to get more details. And eventually, you can add more and more features to Lens extension to cover more functions.
And okay, one more question is that ever since there's new CRD and new custom resource definitions and other things popping up as per need in the Kubernetes cluster, and it's mandatory that Kubernetes Lens support every custom resource definition or other kind of things as they come up during some kind of a thing, those custom resource definitions that we applied into the there, they might have some interaction with some external endpoints or have internal going up. So it's kind of a link that this has egress connection to that endpoint, and then it triggers that to the external APIs. Like just you had said that with it's a good analogy with the service mesh technologies that we have a pod that has a container in it, then have a sidecar in it. So then we figure out in a way that this is happening in the cluster endpoint, and then it's going forward to the extraction API. So that's what I learned what you said about these.
Yeah, exactly.
Yes. Yes. So thank you.
That's exactly what I was trying to say now. Yeah.
Yes, thank you. And also, we see a very good analogy of extension API that we say with the MacOS security team that doing the vulnerabilities reports of images, and then we have leverage in the Kubernetes land. You also they have third-party extension APIs, so you can see directly in the dashboard in the lens that how many vulnerabilities do I have in my images without going into the external dashboards or the Aqua Security external tool. So with leveraging extension APIs, you can see that information. And if currently Kubernetes don't have a support for other tools like Kyvern or other, they can build that extension APIs, and these are easily configurable to the Kubernetes Lens project as well.
Yes, I think the Aqua Security extension is a very good example of this. So they have some resources that they are storing in Kubernetes API, and with Lens, they can easily visualize those or gather information from those custom resources and display those in Kubernetes resource details. For example, deployments. The user will see from deployment itself that, okay, this deployment has some vulnerabilities. And what we can improve in Lens, so we can allow extension developers to build some overall view from those vulnerabilities. For example, this cluster overview page, there we can raise all those vulnerabilities that are cluster-wide. So cluster admin can see in one side that, okay, these are the issues in my cluster. So he or she doesn't need to go into deployment details to see, is this deployment vulnerable?
Yes, definitely. I think Kubernetes Lens has really what you just showed tonight. You can do so many things manages with using the Kubernetes Lens. It's a very good tool, not only for the devs, but also for the ops field, for the DevOps people. It's a go-to place because Kubernetes is highly extensible, highly configurable. There is a lot much going on in the Kubernetes when you bootstrapping the cluster. So many they have Kubernetes let have support for everything by default. You can do chaos engineering. You can do extension API to integrate third-party solution. So this is a very good. That's a very tremendous tool, Kubernetes Lens. And I learned why this is so popular. One of the popular tools in Kubernetes IDE, and I really enjoy a lot during your discussion. And we hope to get in touch with you in the future and going at some other sessions of Kubernetes Lens as things are evolving and the cloud native ecosystem are ever growing, ever evolving ecosystem. So there's we can contact you again. But tonight I learned so many good things from you, and definitely try that out what you have showed you here. So Larry, just last few words. Where do people find you if after the session they want to get in touch with you or want to know more about Kubernetes Lens as a team, as a you, what you are doing on, and want to get in touch with you?
I think the easiest way is to join our community Slack, and you can find that Slack address from k8slines.dev site. Go to Slack section and join our Slack channel. I'm here. I'm there. There are other people that are willing to help also, so I'm not the only one there. If you have any questions or issues, just ask. We will provide help.
So thanks again, Lauri, and thanks again for Kubernetes Lens team for having session with us. and we hope to see you in future. We have a very good wishes for Kubernetes Lens project. They have gained a tremendous amount of popularity, tremendous amount of recognition in the Kubernetes ecosystem. So best wishes for you and your team, and you've done a very good project. You've done a very good job of maintaining this project. So everybody who are joining us today, we hope you learned a lot from this session. So if you have any question, you can put them in chat in our YouTube channel. We try to answer your question as we're moving along. And if we highly recommend you to join the Kubernetes Lens Slack channel that's listing here in YouTube chat, and you can find a wider community there to help you in or if you get into trouble along the way. So thanks everyone for joining. Thanks Lauri. We hope to see you again in future. Thanks everyone. Bye bye.
Thank you. Bye bye.